If you look at different tissues, um, they have the exact same DNA. Liver cells are identical in their DNA sequence to gastric cells, to skin cells, and what have you. The only difference is how that book of life is punctuated and organized. And the corollary of this is when you look at inherited cancer syndromes. For example, BRCA gene, when it's mutated in a woman, they will get breast cancers. If BRCA2 is mutated, they will get ovarian cancers. P53 will give you Gardner syndrome. APC will give colon cancers. Even though these genes are expressed in all tissues, when they are inherited as with a mutation, you don't get cancer everywhere. And if you extend this to sporadic cancers, there are two main molecular pathways in the development of colon cancer. The sporadic ones are driven by APC, KRAS, and P53 mutations, and they happen to be predominantly in the distal colon and sigmoid. Whereas the microsatellite instability associated colon cancers are in the ascending colon. Again, these genes are expressed in all tissues. Why is there such a specificity in location? One answer came from a very elegant experiment on retinoblastoma. As you know, when this gene is inactivated, it causes newborn or early childhood eye tumors arising from retina. And retina has 7 layers, and these authors altered the retinoblastoma gene in each layer individually. And what they found is that 4 of the 7 cell types, when RB is inactivated, cells die, not giving rise to any tumor whatsoever. The other 3 do give rise to tumors. So the reason I'm showing this is that first I told you tissue origin differences, and then we at the individual level, in the colon example, we looked at one organ. Now in the retina example, we're looking at different cell types in the same tissue. And in prostate, interestingly, the green area is called peripheral zone, and 90% of prostate cancers arise there. Why not in other areas? They are exposed to the same oncogenes, same chemicals, same hormones. So these examples should give us the confidence that different tissues, different cells are not a blank slate where genes act upon. Cells are an active participant in this cancer development story. And after almost 30 years of focus on genes, this paper came out a couple of years ago in 2018, where the authors examined 10,000 tumors. This is a massive study in 33 types of cancer. And the title says it all. Cell of origin patterns dominate the molecular classification of 10,000 tumors. This was independent of genetics. So that brings us, what other factor are we missing? And that brings us to the topic of cancer stem cells. So until now, I told you the genomic story, which in this figure is the left-hand side, the clonal evolution. The right-hand side is the timeline of cancer stem cells. As you can see, early on, before 1970s, there was a lot of work on cancer stem cells and a lot of progress. But after 70s, with the advent of molecular biology, after discovery of DNA, the double helix, the genomics research took off. But now in the last 10 to 15 years, cancer stem cell area is getting new attention. So before I get into the specifics of cancer stem cells, let me give you a few general rules about how it works. So if you look at change in cells, it can happen through three mechanisms. At the top, you go from a non-tumorigenic to tumorigenic cell, and if it happens through a DNA mutation, it's essentially irreversible. For a mutation to revert back is 10 to the minus, I think, 18 or something like that is a very large, very small possibility. The second kind of change is reversible. Let's say you consume some sugar, your pancreas responds and secretes some insulin. It's all happening at the protein level. And your cells want to go back to homeostasis, because otherwise, if you just ate, a big meal and then your insulin was upregulated, and if it stayed upregulated, it's not compatible with life. So a lot of regulatory events are happening at the protein level, and it shifts back and forth depending on the environment. The third type of change is what we focus on, is the epigenomic changes at the chromatin level. And these are reversible, but rarely. And they have a hierarchical relationship between the parent cell and the daughter cell. What I mean by that is this. On the left are regular cells. When they divide into two, they produce two identical copies. On the right is how stem cells divide. And the definition is it's asymmetric, because one of the daughter cell is a stem cell, so it regenerates itself. That's the green color. And the other cell is a non-stem cell, red. So the rule number one is stem cells divide asymmetrically and non-stem cells divide symmetrically. If you look at rule number two, stem cells have infinite lifespan, because at every division, they create a daughter cell that's a stem cell. So the lineage you see numbered 1, 2, 3 is with the arrows, that's green, that can go for a lifetime of an organism as a stem cell. But the daughter cells will have finite lifespan. And let's say that the second generation that are shown in white are terminally differentiated cells. That is, they cannot divide anymore. So the stem cell gives rise to a stem cell and a non-stem cell in the first division. And then that first generation red cell gives rise to two red cells. And then in the next cell division cycle, they stop. So this assumes that the red cells have a one division cycle and the next, and that's it. Their lifespan is 2 cell divisions. So if you just use these two rules and run the scenario over and over again, something interesting happens. So in the first division, the ratio of red to green cells is 1 to 1. In the second division, red to green is 1 to 3. In the third division, the ratio of green, red to white is 1, 3, and 4. But then you reach a plateau, and no matter how many cycles you go through, the ratio will stay the same. So these simple rules actually allows a multicellular organism stay the same size. So how does this impact our thinking of cancer? So if you look at the example in the left, let's say that cancer is driven entirely by genetic mutations and they're not reversible. So let's say that you took a tumor that's a mixture of stem cells and non-stem cells, mutant cells and non-mutant cells, and then purified them into red and blue populations. You inject it in a mouse, what you should get is red cells should give you red, blue cells should give you blue, because they can't go back. If it's a reversible event, even after you purify them, when you inject them in a mouse, they will go back and forth, so you'll get two mixed populations. But if there's a hierarchical relationship where the red cells can give rise to blue cells, but the blue cells cannot, then the two arms of the experiment will be different, which would be the example of a hierarchical event. And this is exactly what experiment was done by Max Wicha and Mike Clark, who published this seminal paper, Prospective Identification of Tumorigenic Breast Cancer Cells. And what they observed is that when they isolate different cell types, only one of them, depicted here as red, give rise to a new tumor in the mouse. If you injected the other cells, you don't get a tumor. That would make it a tumor-initiating cell. What makes it a cancer stem cell is that the red cell, when injected in a mouse, recreated the entire original heterogeneity. That makes it a stem cell. So cancer stem cells share some properties with normal stem cells, which is self-renewal and differentiation capacity. Some malignant aspects of this is that they are particularly adept to initiating tumors, metastasis, and relapse. So why are they relevant for us is that it's thought that most of the standard cancer drugs do not touch cancer stem cells. They kill all the other cells. So that's this arm at the bottom. So a drug kills the red, green, blue cells, leaves behind the cancer stem cell, and basically then the tumor will come back. This is the theory why most cancer drugs do not work. So with that idea, there are a lot of trials working to target cancer stem cells. And this is a list from 2018. It's ever increasing. We don't have a silver bullet perfect cancer stem cell drug yet, but trials are underway. So I reviewed for you both the genomic and non-genomic journey we took in cancer research since the 90s. I'm going to talk about how I apply this knowledge to what I'm doing. So if you look at breast cancer, which is one of the areas I focus, there's an ongoing debate about how to classify them. So this table shows you all the complexity. There's 18 subtypes according to WHO classification. And then each of these columns is another group proposing 3 subtypes, 5 subtypes, 10 subtypes, and nobody's sure how many there should be. So I looked at this question from the perspective of lymphomas and leukemias. As you know, if you are familiar with lymphomas and leukemias, you will hear terms like follicular lymphoma, mantle cell lymphoma, diffuse large B cell, and so on and so forth. The reason they're named that way is that because each of them have a normal counterpart cell of origin that determines that phenotype. So in order to classify a tumor, one could approach it like evolutionary biologists classify all biology. To organize the species, you start with the most general classifier, and then each classifier is used once, each step constrains the next, and number of entities increase with each step, and you cannot eliminate steps, and data integration is vertical. So you can develop an analogy to kingdom all the way down to species. Think of them as organ, tissue, cell, DNA, RNA, and protein organization. And there are millions of protein species, about 300,000 different RNAs. We know we have 20,000 genes. So they have the arrangement where every layer you have more and more entities. And we know pretty much everything about DNA, RNA, and protein. We sequenced the human genome. We know our organs and tissues. The missing piece was we didn't know our cell types well. So I approached this problem in collaboration with Sandro Santagata, and many years of research gave us this picture. This is an actual human breast tissue that's false colored, and each cell type is colored in a different way. So there are 11 different cell types. What happens is that if a cancer starts in a red cell, it carries that feature. If it starts in a green cell, it carries that feature, and so on and so forth. So we've shown this using a lot of molecular tools. And based on this, we discovered that there are 10 cell types in normal human breast, and that they have a differentiation relationship. Most differentiated cells co-expressing estrogen, androgen, and vitamin D receptors. So we call them triple hormone receptor positive, or HR3, and the cells that do not express any of these hormone receptors, we call them HR0, being negative for all, and then you have all the permutations. So these are all the different normal cell types, and what we found is that tumors, while normals have all these cells essentially coexisting, tumors are stuck in one arm of this tree, in one branch. And every tumor, though, followed this template. And when we looked at the differences between those tumors that express all three hormone receptors versus those that do not express any, there was a 7-fold difference in survival in multivariate analysis. This compares favorably with genetic testing, where the hazard ratio that tells you the highest risk is in the range of 1 to 4.6 maximum. So our cell type or cell origin based approach was very powerful. So a few words about epigenetics then. We've just shown you that it can make a 7-fold difference in a breast cancer outcome. If you take a human DNA and stretched it, it would be 6 feet long. So the only way to fit it in a cell is to pack it and wind it about 10,000 times. And this is done around so-called histone genes. And this is how, even though you have the identical DNA between nerves, bone, muscle, skin, you get different cell types because the epigenomic marks around these histones are different. That's how you get the different cells. And these marks are placed on the DNA by enzymes called histone deacetylases. There's 11 of them, and they mark the DNA. There's also methylation that marks the DNA. And when DNA is acetylated, it opens up and genes can be transcribed into proteins. So what we found in my research is that a couple of these histone deacetylases, HDAC1 and HDAC7, is highly expressed in cancer stem cells, but not in regular tumor cells. So we think that this really explains the difference. So I will stop here and tell you that cancer is the product of an interaction between genes and cells and microenvironment. So just looking at oncogenes is not going to tell us what will happen with a particular patient. We have to pay attention to what's going on with their cells and cell origin. So this is my summary. Tumors initiate in a spectrum of normal cells called cell of origin. Similar to normal tissues, tumor cells also differentiate. Tumors are composed of cancer stem cells and their more differentiated progeny called non-stem tumor cells. Cancer stem cells self-renew and they are immortal. They constitute a very tiny fraction of the tumor bulk. They can be as rare as 1 in 1,000 tumor cells. Only cancer stem cells can give rise to other tumor cells and metastases. Most existing drugs are not effective against the tumor stem cells. Therefore, reduction in tumor bulk may not be a good measure for determining effectiveness of cancer stem cell targeting drugs. And we believe that when we have better drugs that target all of the tumor, both the stem cells and non-stem cells, perhaps we may have a more effective approach to cancer treatment. So I'll stop there and take any questions. Thank you.
Dr. Dan, very great presentation. I believe you have lots of questions here. Dr. Cheryl, do you have any questions? Dr. Joseph, are you there?
I have a question. So you're telling us that these cancer stem cells have like infinite life. So if we use like the current CRISPR technology to target the cancer stem cells, does it switch it? Is there a possibility of switching that back to normal when you optimize the rest of the environment and nutrition?
Yeah, interesting question. So CRISPR technology, as far as I know, will not be able to change those marks on DNA, right? You can insert a gene, take out a gene. So I don't think that there's a practical way of turning a stem cell into a non-stem cell using CRISPR, unless we found a master regulator and you take out that gene with CRISPR. So what I would say is that my research suggests that that gene master regulator of cancer stem cells may be HDAC7. So targeting HDAC7 with CRISPR possibly be a tool. The problem is, how do you, so to speak, surgically do that only in cancer stem cells and don't touch the rest of the body? That's always the problem in cancer.
You're right. I think CRISP will not work because it's only right now designed for only specific gene segment,
Yeah.
one gene, not for multiple genes. And in cancer, you have multiple genes errors, and also epigenetics as well. We don't have the technology that will fix multiple genes, and so I don't think CRISP technology is yet mature enough for doing anything for cancer cells. But cancer stem cells, the reason that I believe that they are different from differentiated cancer cells, first, their antioxidant capacity is higher. It's more powerful than regular cancer cells or adult cancer cells, or differentiated cancer cells.
That's correct.
So that's one. So they are resisting the free radicals that's been generated from chemotherapy, radiotherapy, or photodynamic therapy. So you need to add drugs that will increase sensitivity of the genes of the cancer stem cells to those free radicals, and polyphenols, CBD, berberine. Berberine also activated p53, high dose. I think this will help to a certain limit, but still we don't have very effective drug regimen for cancer stem cells, and they are very sneaky. They hibernate when they be exposed to the radiotherapy, and this is what's happening even to many cases that I've been treated, including my dad. You destroy everything. It's just little small mass still there. It's active, and they don't divide when they're being exposed to radiotherapy. They hibernate. They become quiet. Once the threat is being lifted, like radiotherapy course is ended or chemotherapy course is ended, then they start proliferating, differentiating. So they are very sneaky. And then you have the microenvironment that the tumor is changing. They are able to suppress the cytotoxic T cells by expressing the PD-L1 receptors. They're secreting cytokines that will polarize the immune system away from Th1 into Th2 and Th17, and they are stimulating fibrotic tissues, which will squeeze the blood vessels, preventing cytotoxic T cells from getting into the cancer. They are changing the vascularity of the cancer, making it tortuous and kinky, where it will be easily squeezed and preventing cytotoxic T cells from going in. And also they are inhibiting the mitochondria, because the mitochondria is like a bomb inside those cancers. So they inhibiting the mitochondrial, so they switch the whole metabolism into anaerobic glycolysis. And so that's why we need to consider activating the mitochondria using all those polyphenols and many other things to switch the metabolism from anaerobic to aerobic. Possibly that will stimulate the mitophagy and destroy the cancer stem cells. So there's multiple drugs and therapeutic targets that needs to be addressed at all different levels, including how you can deliver drugs specifically into the cancer using nanotechnology. And that's what we're doing in our group of coronary disease prevention management. We're using platelet-derived nanoparticles and loading the antibodies that recently we call them the immuno-oncologists. They are very happy about it. But the problem with antibodies by itself, it's naked, it goes everywhere, cancer and healthy tissue. So loading them inside platelet nanoparticles may help to increase the targeting into the cancer. Chemotherapy, we're loading it into platelet nanoparticles as well. Photosensitizers, we're doing it the same. Also the polyphenols and many others to target all different aspects of the cancer, changing the microenvironment, increasing sensitivity to free radicals. So the way that the way that the mainstream medicine are doing, I don't think I don't think it's effective. Some people, they will say, oh, would you just do immunotherapy? That's not going to work. You have to combine immunotherapy, chemotherapy, nanotechnology, metabolic therapy, and redox therapy in order to really hit the cancer from all different angles. Otherwise, we're shooting in the dark, and the cancer is able to develop resistance by changing the microenvironments, and able to kick out or expel those chemotherapy using pumps and receptors. So, but using nanotechnology definitely helps to break those resistance a lot. And that's what we are doing when we're having this training program for our network of doctors. We teach them how to develop nanotechnology using platelet-derived nanoparticles. And that's why, Dr. Tran, I'm trying to see if we can collaborate together, and where you can start also using platelet nanoparticles and see if that will help to increase the efficacy of the treatment at the lab level and come up with some more evidence and more studies. That's something I want to talk to you about it, if that's something you're interested in. I don't know if you have any exposure to using that technology. I mean, you may have exposure to using PLGA liposomes, but the problem with those synthetic deliveries, they are being having problems, which they are being considered as foreign in the body, and the macrophages of the liver are taking them, so they are being hindered to reach the target. But using the platelets nanoparticles, it's like a torsion. Your macrophage will recognize it as self, so it gets into the pathology. Whether this pathology is cancer, whether this pathology is phagosomes, inflammasomes, senescent cells. So we use this nanotechnology not for cancer, but also for treating autoimmune disease, inflammatory diseases. Also, those platelet nanoparticles target a virus and bacteria, and any inflammatory area of the body. It has the tendency to attract and stick into those cells. So I don't know if this is something may interest you to integrate the protocols and the way that we are using it in 10 clinics in the United States. Bahamas is the 11, and then we have Germany. We just got a recent center there. But if we have connection with university labs where they can test what we are doing to confirm our clinical work of using platelet nanoparticles, that would be some great advance that we can work together or collaborations. What do you think?
Well, I wouldn't use the term interested, not interested. That's not the issue, because what you're explaining to me is very interesting. The problem is, do I have the laboratory resources to do something like that? And I do not have, unfortunately. I have a very small laboratory right now, just a couple of people. I recently became the chair of a department, and so I'm more focusing on sort of developing the educational training aspect of my department. But I'm sure that there may be individuals who may be interested in, collaborating. Do you have a publication or some information you can email me that I can share with them?
Yeah, sure. We have already publications, not mine. I do have two publications in Harvard Medical School, but is not specifically the protocols that we are currently doing it in the clinics using platelets nanoparticles. We develop a certain program of sonication and nanofiltration, and it works very well. We have very good result. I think Dr. Joseph James, if he is here, he will share with us his experience of turning a patient with a stroke and multiple infarction back to life. Dr. James, are you there?
Can you hear me okay?
Yes, I can hear you.
Okay. I'll put on the, sorry, I was going to try to put on the video, but it's not turning. There it goes. Okay, so yeah, I've had a lot of success with the platelet-derived nanoparticles. The most important case I've had was a 33-year-old male who contracted COVID. He had diffuse thrombosis. He had heart failure, myocardial infarction, pulmonary embolism, ischemic stroke. He had 8% ejection fraction. At the time that I treated him, he was on a milrinone drip. He had no motor dysfunction. I saw him at about 2 months status post his acute event. And he had slurred speech. He was alert and oriented, no motor dysfunctions, but a lot of fatigue, obviously. And he was on, like I said, a milrinone drip just to keep him alive. I treated him with, I loaded placental derived nanoparticles, the exosomes, and I treated him with the platelet derived nanoparticles. I loaded them with antioxidants, methylene blue, to buffer the redox, along with high dose of N-acetylcysteine to also help dissolve the thrombosis or to prevent any further thrombosis. And I also treated him with photodynamic therapy with the light that Dr. Halassa had started me out with. It's more penetrating. And I also used a breathing machine. It's really not a breathing machine. It's sending a bioidentical infrared signal through water vapor with the purpose of translating that energy onto the body water to put the body water, intracellular body water, into a fourth phase that they've studied extensively. The water scientists have shown that this device triggers structured water, which is more effective at causing proteins to fold up or damaged proteins to become active by folding back up. Collectively, it's like what Dr. Halassa said. It's doing all these things at the same time, covering all the pathways. I don't know what the genetic approach would be for it, but here's the good news. We are at about 4 months, and now I have to talk to his cardiologist. I have to find out what the results are, because he had a cardiac cath, and based on the cardiac cath, what the family told me over the phone, he's in another state. That's why I haven't seen him physically, that his heart is normal for a 33-year-old male. So, I don't know what that says about the ejection fraction. I do know that he's working out at the gym, doing light exercise, light dumbbells. He's on a, what do you call that, treadmill, that like cross country skiing. He's working part-time at his family's business. He lives in West Michigan. I'm in Chicago. His slurred speech is almost unnoticeable, and he can walk up to 3 to 4 miles, and they are decreasing his milrinone, slowly weaning him off. I don't want to get overly too optimistic, but what we did made a difference, no doubt. I think it's going to change everything, but let's wait till we get the data. Let's wait till we get the numbers, put everything into perspective. But I mean, we're talking 8% ejection fraction to almost normal, according to what the family says, in 4 months. I don't know if that's even possible without some incredible intervention, something way ahead of, whatever we could have done. Even if you did stem cell therapy, I don't believe that the stem cells would even get into the myocardium. If you have the light shining, penetrating deeply onto the myocardium, my understanding is that the nanoparticles they're attracted to heat, and that they are small enough that they can get into hard to reach places because they're nano size. Stem cells can't even get, half of them or a lot of them cannot even get past the lungs. So we're operating on a whole nother level. That's all I can say about that. And I did recently start treating a woman, 73-year-old female with stage 4 rectal cancer, metastases to the liver and colon. The daughter, it was my PA's friend's mother, and she was desperate when they asked us to go over there and try to do something because her mother was dying. They had no pain control. The mother's laying in bed, moaning, confused, dry mouth, could not get out of bed. And blood pressure was 80/60. I think what our parameters, I think she had a low-grade fever. And we gave her an IV. We actually did take enough blood to be able to spin out the PRP, sonicate it, load it with the methylene blue and acetylcysteine. I believe we even added some vitamin B12. I'd have to look at the records. Thymosin alpha peptide to boost the production of natural killer cells. I mean, we were just hoping for a miracle. And the next day she woke up, got out of bed by herself and went to the restroom by herself. And her belly has progressed. We've treated her twice a week now for the past 2 weeks. So we've done, I think, 4 or 5 treatments, and her belly pain is gone. When I tried to give her fluids, it third spaced. That's how severe she was. Most of the swelling is gone from her legs. Her belly, her ascites is basically gone. Her belly's soft. She doesn't have belly pain. She's moving her bowels with the help of enemas. We have hospice on the case. And, that situation is different because we were able to use this technology, the way I see it, to buy her some time, to get hospice, get comfort measures in place, have family members be able to visit her. I don't know exactly, she wants to go all the way with this. So I brought up the idea of adding some chemotherapy agents, maybe some that they could afford. You don't have to add that much. That's the beauty of it. It makes sense. If all the nanoparticles are going to the light and to the inflammation, well, you don't need to give a large dose. You only need to give a fraction of the chemotherapy, from what I understand, which makes sense. And now that I understand that, okay, the cancer is smart, it could be hiding, the blood vessels are kinked, it's suppressing the natural killer cells. We have to stay with it. Right now, it's like we do the treat. In fact, she even says she feels better. The daughter says she feels better after the treatments for a couple of days. But then as it's getting into 3 to 4 days, when we see her again, she's starting to feel not as good. And then we do the treatment and then she starts to feel better. So I can see how, we have to cover all the pathways the best that we can. And that's the message.
Al, first of all, congratulations for such a dramatic success. Sounds great. outside my expertise. I'm only working on gynecologic cancers, and I'm not someone who is treating patients. So I will leave, drug treatment, drug development to those who really know what they're doing. I don't consider myself an expert, but I'll be happy to connect you if you send me some material, even if it's not your technology, if it explains the technology you're using, I'll be happy to share it.
Yeah, no, thank you. All I know is that the results are speaking for themselves. I've been doing regenerative for long enough now to have a sense of, to be able to compare it to what I was doing 4 or 5 years ago. I did do a fellowship in regenerative. I have about 10 years experience. Working with Dr. Halassa for over a year now. I mean, that really took my education to a whole new level. But what I can say is that even the basic cases with the nanoparticles or platelet-derived nanoparticles loaded, combined with the acoustic wave as well. Say if you're treating musculoskeletal, and of course we use the acoustic wave with the cancer. That's the great thing. Every patient is a little bit different, but like I treated my sister's shoulder, and she's had crepitance and for many years, and she can only use it so much that it gets sore consistently for many years. And I could tell you that the results they're actually and they're fast. With stem cell therapy, I had to wait 2 to 4 weeks before the patient felt any different. Sometimes 6 weeks. With the nanoparticle, with the new techniques and combining all the, not just shooting in the dark, but doing it, optimizing the things that are appropriate, considering like vitamin D, doing a full workup, not just bringing people in and just sticking stem cells in their knees. The results are impressive, and they are fast, and they are cost effective. To treat this woman, even with the cancer therapies, I mean, the cancer approach, I mean, how much really does it cost to draw blood, use a centrifuge to spin it, and then process it? It's really not costing anything. I mean, obviously the cost of the equipment, but that pays for itself really, really quickly. It's exciting. I think there's a whole new window. This is a game changer. If you can go to somebody's house and you can treat their cancer like that. I mean, who does that? That opens up a lot of avenue and a lot of possibility. Then we start combining peptide therapy. We start thinking, again, not shooting in the dark. We're thinking in terms of how important vitamin D is. I have a biophotonic scanner now that I got so that I can measure the carotenoids, because that's another piece of the oxidative stress challenge is optimizing. And when I say optimizing, I mean optimal, more like a 25-year-old, because 25-year-olds heal faster than us, right? And then, vitamin D does not get absorbed if the carotenoids are not optimal. Now we're looking for a really good, solid gut optimizing plan. I think concentrated plant enzymes, they're immunomodulatory. They break down the mucous membrane that shouldn't be in the small bowel, that's contributing. We're repolarizing the immune system. We're thinking in terms of Th17. I mean, did you know that most of the chronic conditions, autoimmune diseases, they are polarized to Th17? I mean, they might also be polarized to Th2 or Th1, depending on which disease. And yes, it's determined if somebody has, say, neurological symptoms from Lyme disease, it may be that they had the epigenetics that caused them to get it. Or if they got rheumatoid arthritis, but they didn't get diabetes type 1, I suspect what you said, based on what you said, that may have had something to do with epigenetics. But the polarization of the immune system is consistent. And to see it from a Th17 polarization, honestly, it makes a lot of these like psoriasis, rheumatoid arthritis, if you're repolarizing them at the same time that you're buffering the redox and you're modulating the immune system with the growth factors from the nanoparticles, I mean, these things are actually really easy to treat. That devastating diseases become almost like an afterthought really quickly. And that's not an exaggeration.
Right. I think
So
Dr. Patel will back you up with her own experience. I don't know if Dr. Patel is here.
Okay. Yes, you're right. I have treated my patients with the breast cancer, ovarian cancer, prostate cancer. And if it is a metastatic stage 4 disease, it's a challenge. Currently, I'm taking care of one ovarian cancer patient where I have done the intertumor injection of PNP conjugates. So I don't just call platelet nanoparticles, because when we are administering the substances with it, I call as a PNP conjugates, because that's what the science describes it as. And we have a good response, but like a very, very hard tumor, you inject and then you provide the photodynamic treatment, and followed by or even simultaneously, you can provide the shockwave treatment, and patient's tumor really palpably, you can feel that has got softer. So you are making the changes in their microenvironment and hoping that medicine spreads into it and takes care. Do I cure them? Probably not. Do I give them the extension of life? Probably yes. Do I make any changes in how she feels? Yes. This patient has been supported by also the nutrient therapy based on her cancer tumor cells sensitivity. And we've been treating her with also the high dose vitamin C, which is sensitive, and curcumin, she's sensitive, and artemisinin, she's sensitive. And we also give her the coffee enema and some other supportive substances orally. But when they are doing better physically, then they're mentally they are better. So they sleep better, they eat better, and mentally better, because in stage 4 disease, to achieve that dynamics is not very easy. It's very powerful to keep them in a good psychological state, along with the emotional state and their physical body.
Yeah, I can agree 100%. I think until you actually are witnessing somebody dying, right in front of your face, and seeing how the family is reacting, to create that kind of, to be able to, first of all, buy them some time to get comfort measures on board. That was my situation specifically. But yeah, I mean, now she's eating, she's talking, she's communicating, she can walk on a walker. She had time for other family members to stop by. She actually has a sense of hope, you know, that, okay, well, let's keep going. I mean, it's just, it's priceless.
In my patient's case, you know, if I can contain her tumor, then I can send her also for the debulking procedure. And so then the tumor load is lower, and meaning by that the spread will be slower. And this way we can buy some time.
Yes, exactly. You know, we bought time that, okay, we can maybe order some of the chemotherapy to do maybe more extensive treatments. Like I said, if it's a lower dose, it's not going to have all the side effects. Nothing near the side effects of regular chemotherapy. They're in the comfort of their own home. This has just never been done before. I mean, as far as I know, it's something, it's weird that it's happening. We're doing it, but I didn't even think about it. I only did it because I learned from Dr. Kalpana, from you, what you were doing. And because I have the experience I have the equipment, it was just a very similar approach.
Change the gear, right?
Change the gear.
Right. That's what you did. You were taking care of the persons that developed the stroke and other problem, and you made that patient better. Now here comes the cancer patient. So you just change your gear in the thinking now how you are going to approach this. And you can give all of the above. Like I did the platelet nanoconjugate treatment on this patient. I gave her the intravenous, I gave her the intratumoral injection, and sometimes I gave her 3 times a week treatment and twice a week IV treatment. So you just spread it out, and she did get chemo, and she had also immunotherapy and peptide therapy. And I also used the photosensitizing dyes so that we can provide the optimal photodynamic therapy with the hypothermia, because the photothermal therapy is very effective. But no matter what you do, just like Dr. mentioned, that cancer stem cells are just so powerful, and they are endowed with the indefinite, and they are immortal. So now we are fighting against the patient's offense, defense. No matter how much we built up, still we just have to wait and see how much we can win the war.
Yeah, and I think that sounds like a realistic, it's not over exaggerating. It's realistic, and it's not saying there's a cure. We cured it. Obviously, I always celebrate, success. To have like that 33-year-old guy who basically was told he was going to have a normal 33-year-old who suddenly is faced with the possibility of a mechanical heart transplant. That's what they told him. I mean, that's just, to walk into the situation, you have to be there. You have to see how nervous, you got to see the fear in the parents and the sister. I guess I'm so used to it. I just walk in and, I'm telling jokes, and not trying to be a comedian, but I'm used to the pressure. But also these techniques are learnable. Like Dr. Patel said, it's a different variation of the same therapies. You're just putting the photodynamic therapy, pointing it somewhere else, or the route of administration might be different. Maybe it's a musculoskeletal injection, maybe it's an IV, maybe it's a nebulizer treatment, maybe it's an intranasal injection, maybe it's making a nasal spray, but it's all different variations of a common theme. I would like to see how it's possible to get a hold of the other photosensitizer, Dr. Patel, to see, you know, I would like to have,
use
now that I got past this step, I would like to learn how to get to the next step.
Do you use the ICG?
I don't know how to get the ICG. I was just using methylene blue.
No, methylene blue, you can just go superficially, but if you have a deep, like I was treating my ovarian cancer patient where the tumor was very deep, and so we cannot reach that only with methylene blue. So we have to use the ICG dye so that it concentrates into the cancer cells, and then you give the photodynamic therapy, which gives the anywhere from 810 to 860 or 870, and it absorbs it well, because without ICG, it will not be absorbed deep down.
Okay, and I'd also like to try to figure out the best way, the most convenient way to have access to like a fiber optic light.
Right, that is, yeah, sure. It is very, very good, because I was just thinking that if I would have used that that probe in this tumor, it would help, because we are giving the dye, and I injected even intratumorally. So if I have an intratumor probe to deliver the light, that might have made more difference, but I don't know at this point, because I don't have a comparison study, and I have not listened to anybody's comparative. I have not come across anybody's comparative study.
Yeah, because we're the pioneers.
Right.
But you know, I was gonna say one thing too. I suspect that your patients are similar to my patients. You're very well connected. You've either had a long-standing relationship with them, or or what?
Or you develop it during the.
Well, I mean, my point is yeah. I mean, I guess I didn't know the two patients, but they knew somebody that knew me. So it's not like we're out there advertising and running cancer clinics by any means. It's just simply a result of people asking me, because I've been doing these kinds of things, people that I know very well that trust me, asking me, can I help? You know, they're scared, or is there anything you can do? So I get sort of pulled into these situations, but because it's, you know, it's private, there's a familiarity to it, and I believe in it. You know, I don't see, and I believe that it's safe. You know, what we do behind closed doors, that's up to us. We have to just be, you know, keep it between us for the most part. That's just the way it is. I don't think it's fair, but it is what it is. But I think, well, I'm going to do it anyways. That's just me. You know, I mean, the heck, if I'm going to be punished for helping people like this, and just then fine. I mean, it's just the way I am. Like I'm not going to stop doing it. But I also don't think it's unsafe. I don't think it's.
Have a good consent form.
What's
Maybe
that?
you say that you are not an oncologist. You are not this. You are not that. You are not this. You are just helping the patient. So then you and patient has signed that. So we have not kept the patient in dark at all. Before I touch the patient, I give them and I said, you have to you have to understand that this is what I practice is integrative oncology, and I'm not an oncologist. And but I have the techniques that helps how to deliver the drugs and make them more effective. Isn't that
yeah, I like that. So basically, it's just transparency. You're not trying to be something. You're not saying you're something that you're not. But you know, at some point, I think this is obviously what happened to you. It's happened to me. You start to see that all of these diseases have a commonality.
Right.
You don't have to, you know, it's not like, oh, I'm not a neurologist, I can't treat that. Oh, I'm not a gastroenterologist, I can't treat that. They have oxidative stress that has no boundaries. Inflammation is common, and we're treating the common. But the reality is that, you know what, maybe it's been the system has made it more complicated than it actually really is. And I think that's
you already have chronic disease prevention management centers being opened by big universities like Johns Hopkins. They have a department for that because they see the specialties. They fail to manage their chronic diseases because let's say if you have patients with Alzheimer, you cannot just manage it by giving drugs that increase acetylcholine like neurologists are doing. You need to work on the leaky gut syndrome. You need to work on detox. You need to do nutritional. You need to give them all the supplements they need to regenerate and buffer their redox and fix all the metabolic errors. That cannot be done by medical specialty. It really needs to be done by chronic disease prevention management specialty, where you are improving the quality of life of the patients, whether they are in cancer or infection or degenerative disease or autoimmune diseases. It's a new branch of medicine. It is sort of integrative medicine, functional medicine, but it's more kind of related to the mainstream medicine because we're using the same drugs, same protocol, but with less amount of drugs because we are adding the target therapy, the nanotechnology. We're activating those drugs with light. So we are kind of improving it and making it more effective in minimizing the side effects and breaking the resistance, whether the resistance for cancer or infection. So we have all these things that we're adding. So you are introducing yourself as improving the quality of the patient's life. And if it happened that you're able to cure, but most of the time chronic diseases, we can say if you're able to induce remission, that's a great success. If you're able to improve the quality of life, that's great. If you're able to slow the progression of the disease, that's all considered success, but you're not claiming any absolute cure. You're not claiming that you are oncologist and you are using high dose of chemotherapy where you need to have a hospital situation because all this high dose chemotherapy do have tremendous amount of side effects. Patients can end up with ICU. Using lower dose as much as you can, very tolerable for the patients. And using high dose chemotherapy, it's an old school, and they have limited courses because if you go beyond that course, you start suppressing the immune system, you're making the cancer to flourish and make it even more worse. So that's why the mainstream protocols, they have regimen, they have certain limits of amount of dose that they can do, whether it's radio or chemotherapy, and they cannot do more. But in your case, using the lowest dose, so you can do more frequent and with less side effects because you're getting those drugs into the cancer tissue. So it's kind of a new approach. A new way of looking things together based on recent publications, and you're translating it into an effective protocol to help to improve the quality of the patient's life. And if you introduce yourself in that way as a chronic disease prevention and management, as an integrative doctor, then definitely you just completing or adding what their specialties are doing in a more comprehensive and more integrative and holistic way, then yes, you are on a safe side. And you're not using any non-FDA drugs. Everything you use is FDA drugs. You're repurposing it. According to the FDA, it's okay to repurpose any drug that's been FDA for any clinical application that you think is right. Just you have to have very nice consent letter. And I think all of you do have that. And we encourage more doctors to join us as well.
So I treated a patient of mine whom I've been taking care of his Lyme disease for a while. And he's 86 years old. So as he got older, then I noticed that he was having the change in the expression of his face, and I didn't think his balance was as good. And gradually he developed tremor, and I told wife that he needs to see a neurologist and diagnosed Parkinson's and put him on the medicine. However, his chronic fatigue got really bad. So I told them that, we can do some newer nanomedicine treatment, and I explained them. And I started that, and after second treatment, his wife is asking me, "Doctor, are you giving him anything for his Parkinson's?" Because he started feeling better, and he was smiling. His color got better. He was not spending as much time in bed. He was watching games, and one day when he went on a golf course and played golf with his old friends. So I think, and what I did, also treated for Lyme in a microdose. If we can give the chemotherapy in a 1/10 of a dose, why can't we treat with the antibiotics the similar way? So, and it is working for him. So I just want to let others know that there are ways that you can manage your patients. You just have to be creative. And if it works, and if it doesn't work, then ask yourself, why it didn't work? And what do I have to modify? Where do I have to go? What do I increase? What do I decrease? And he was having such a bad neck pain. So I marked that, and when we provided him the Cura laser, which is YAG laser, and we gave him treatment, and his neck felt better. So, and he did not want a helmet for the Parkinson's. We wanted to treat him for that, but he didn't want it. So you don't force them on anything. You explain them, but if they do not want, and he is the person that who is a claustrophobic, so he doesn't even want to go on the whole body laser machine. Forget about the hyperbaric machine. So you are constrained, but within that, you can treat patients very effectively, and they get better because I think to stop the progression of Parkinson's, if you're not able to reverse, is the best thing you can do.
Yeah, absolutely. The one thing I've learned is everything isn't this or that. Did it work or does it not work? Well, obviously it doesn't. Well, this is me just being humorous, but it's kind of true. I mean, well, what else is working? I don't really see anything else working out there. Okay. I mean, let's be honest, man can never match the beauty and perfection of nature. That's the man who actually, G. Edward Griffin, I actually interviewed him about 10 years ago. No, maybe I think it was 6 or 7 years ago, actually, now that I think about it. He wrote the book, A World Without Cancer, in 1970. And that's what he learned. He wrote the book for his friend who was an MD. He's a researcher by nature, very thorough. And he said, man can never match the beauty and perfection of nature. And that rings true for me. But again, it's not this or that. It's empowering the patients to have hope, to have some choice, to buy them more time. Or like you said, even if you can live, I have psoriasis and my mother is on disability, from psoriatic arthritis. Now, my psoriasis has been dormant for almost 4 years since I've started doing the regenerative therapies. Now I do the nanoparticles. It's easy. I can do it to myself actually, and it doesn't cost me anything. Minimal. Draw my blood, spin it, the whole thing. But the bottom line is, I feel empowered to have some control over my situation, and that's what I'm trying to help when somebody's asking for my help. I'm not convincing people. I'm not soliciting them. Believe me, I know what they need, but they have to see it a little bit and meet me halfway so that I can help give them the choice. Because I've already been there, either with other patients or with myself, to empower them. Because when they're not empowered, when psoriasis gets out of control, or pain gets out of control, psoriatic arthritis, or the autoimmune diseases that are just ridiculous out there, and cancer just seems like it's just running rampant. Like every time you turn around, somebody, I had a patient of mine, his wife just died of cancer, just like that. And I've seen them. Now, I wasn't treating her specifically, but this is devastating. It really is. If you really, really think about it. And autoimmune diseases, the ones, I have patients now that are reaching out. They've got 4 or 5 different autoimmune diseases all at the same time. That is misery. So just to be able to do something more than just, oh, I eat healthy. Oh, I did a juice cleanse. These diseases are so far advanced that diet and exercise by itself isn't going to cut it. And I mean that. We need something to optimize their body to be able to rise, help their body to, the fire is like a wildfire. That's how I describe it. The inflammation, the oxidative stress I describe as like, the actually, like if there's a forest fire and then all the damage, that's like the oxidative stress. It takes a lot of work to bring that back to life. And so that's another way to see it.
Well, the very importantly is that, subjectively patients say, I feel good, better, and all of that. It's good. But I think adding more biomarkers and all those metabolic panels and showing the difference, and also very important. And Mr. Ken has a system of endothelial function and ANS. This gives you very realistic, objective improvement. If you're able to improve the endothelial function test from being poor into excellent, that's mean your overall general health is being improved. If you are treating a sexual dysfunction and you're able to switch him or turning him from poor to excellent endothelial function test, that's mean his sexual function will improve. That's mean his cardiovascular disease will decrease. That's mean his autoimmune flaring up is being decreased. So I will recommend all the integrative doctors to have endothelial function test and ANS and pseudomotor testing as a way to monetize the efficacy of your holistic integrative regenerative therapies, because that's where you can show to the patients you came with a poor endothelial function test. We did all this detox, we did all this supplement for you, we did all this managing the leaky gut syndrome, we did all those photo biomodulation, ozone, redox therapy, metabolic therapy, and now your endothelial function is excellent. That's mean we minimize the risk of death. And you extend the life of the patient. That's what it is. Because improving the function test means improving the telomeres, means that the general inflammation is being subsided, means that the of the will be, your work or your
you're breaking up,
integrative
Dr.
therapy.
Halassa.
Can you hear me, guys?
I'm gonna have to sign off. I apologize interrupting this interesting discussion.
We forgot about you. Oh, sorry.
It's all right.
But we are very appreciated for your presentation. It was excellent, great. Just we're trying to translate into clinical, where people they can really use your experience and in the clinical world.
Well, I really appreciate the invite, and if you email me some material, we'll stay in touch. Thank you all. Have a great day.
Thank you very much. Appreciate that.
Thank you.
Yeah, if you want to go ahead, Ken, and talk about your system and conclude the meeting, that would be great. I don't know if you're there. If not, then go ahead, Dr. Joseph, conclude the meeting if Ken is not coming.
Okay. Yeah, and I did see that Rowena Gates is on the call. She is one of the owners, I guess, of the Nanovi. And did you have anything you wanted to say, Rowena? Just really quickly.
Hello, everybody. No, I'm more than happy. The Nanovi is actually sitting on the shelf behind James there with a arm.
Because it's literally a coincidence, but yeah.
Right. I should turn around. My light's not very good. Yeah, and so really we're just influencing the cellular water to improve protein function by improving protein folding. So if you have any questions about that, I'm more than happy to take them now or later, whatever's helpful.
Well, I think your water is basically, and according to the article that you sent me, it seems like there is buffering of the redox, is reducing it. It's like hydrogen water. That's what I think that's and it has an antioxidant efficacy, because hydrogen water does help the same way, the proteins and buffer the redox and neutralize those free radicals and all those damaging free radicals, and by giving those electrons to neutralize them. So that's what I see. I see it's like hydrogen water, similar aspect. How the light does help to reduce the water, that needs to be more explained in your presentation.
Yeah, the molecular hydrogen is a really powerful antioxidant. And what we do is we really come in later and repair the damage of oxidative stress. So combined, they're wonderful. Recent studies of proteins show that this device called Nanovi also has a preventative side of it. So if it's used before a damaging incident, it also has much better results than the placebo device. So it may have some sort of antioxidant capacity too. It probably does. It's just that what's unique about it is that it helps repair the damage because it's protein activity that repairs damage. And so by supporting that, you let that natural process that James was mentioning kind of take over, and it knows better than we do of what to do.
Yeah, right. And I've been involved with the use of Nanovi. How we met was really an amazing coincidence. It was through a mutual friend in Chicago who saw that what I was doing, and he just sat me down and said, "No, you need to hear me right now." And he tells me about this machine. I'm like, I'm all ears. I mean, because it made sense, but I can vouch for it even by itself. It's one of those big secrets that you uncover this stuff and you realize how deep the science is. This is German technology. It was designed by the engineer Hans Ing, who's your business partner, right?
Yes, and it was designed here in the U.S., but he's from Berlin.
From Berlin. Yeah, so this is high science. It's one of those things you didn't know about it, you didn't hear about it. I'm always saying it because it just fits. It's another one of those routes of administration. It covers another pathway in buffering the redox, helping to modulate the immune system. And they do, there's some things that really stand out for me. That signal, that infrared bioidentical signal that is being carried by the water vapor into, you breathe it in, and that translates into the cytoplasmic water. That's the same signal that is radiating off of the mitochondria, that is naturally putting the water into its fourth phase, which is slightly more viscous than third phase regular water. It's structured. So it's more like a marching band versus just random H2O molecules floating around. It's a higher energy state, and that it can be measured by a photon recognizing camera. I don't know what it's called. But if you look at the energy field before using it, it's patchy, especially when in people like us, we're suboptimal, or especially if somebody has chronic disease. I'm sure there might, the energy radiating off of their body, which is really coming from the mitochondria, is patchy. But then after the treatment, you're more like a light being. That's the,
yeah.
And go ahead.
An institute studied mitochondrial function by looking at responsiveness in the heart, actually, and they could show an improvement in what they took to be mitochondrial function with electromyocardiogram. And so there's definitely a mitochondrial component to it, which I thought was very interesting given the conversation today. And I also think that might be what you noticed. I remember after you used it and how far you could run or something. And it was like, you didn't care about all the medical stuff. It's like, oh my gosh, I can run far.
Well, yeah, I mean, I was just getting to a point where I would run a few blocks. I couldn't run the way I ran when I was 25 years old, where I would just run 4 or 5 miles straight. And my willpower would not get me past my sticking point. When I did the treatment, I felt the same. It's not like I felt different, like, wow, I have all this energy. All I know is that it seemed like my body was utilizing oxygen more efficiently, such that I just kept running. I didn't hit that sticking point. In fact, I had to go to work that day, so I had to cut my run short. But that's no exaggeration. And I'm not surprised when I think having been doing this stuff for long enough, I have a sense for something that's got some real technology behind it. And obviously, most of the stuff that is the best stuff isn't going to be out there. You know, everybody's usually not going to be talking about or know about it. I think it's one of those great hidden secrets. And then once I did jump into the science, you really can't argue against it. I mean, there's enough data in and of itself, but the concept actually makes a lot of sense in the context of oxidative stress. The way I see it, if the proteins are functioning better or enzymes function better at the fourth phase, at the higher energy state, which is probably the state we should be in, you're going to have, better healing of DNA damage, less mutations. But the mitochondria, we talked about this. If you decrease the oxidative stress in the cytoplasm, the mitochondrial function will improve, and then it will start to radiate more of that same bioidentical signal. So it's kind of a cycle.
There's these cascades, and it's relatively easy to measure on the human body. What's the challenge for us is that it's innovative. It's actually a little too new. And let me just clarify one thing, because people are probably wondering. We're actually at the high end of the near infrared spectrum and above that a little bit with the wavelengths that we use. But what it's doing to the cellular water, in our understanding, is it creates this ordered water or structured water that you were talking about, the marching band. And that's a condition your cell needs to be into, because where does the energy for the protein to fold come from? It's just immersed in water. Where does it has to have energy from somewhere to fold into a 3D shape. And so the idea is that it's a transfer of entropy. The water becomes less organized and it donates its energy to the protein so the protein can snap into the folded shape. And so that's sort of the story of the cellular water. And of course, yeah, the body's, it's ordering that water constantly, because that's what
is it distilled water, or you have salt in it?
And our device knows nothing in it, only distilled.
Mm-hmm. So you use distilled water, you don't use salt water.
And we don't want any particles or any corruption in there, because the water that James described, the fourth phase of water, it only forms on surfaces. So we don't want it to go to any surfaces until it's getting into the body. And then proteins are surfaces, any of the cell components and so on. And that's where it'll form these layers of ordered water. And that's what surrounds the proteins and then lets them fold, because they have basically the energy to do it.
And, you know, I just had like an epiphany, you know, if you think just sort of like universal law, that you've got two polarities. You've got chaos and order. And it's funny, I was actually, somebody was telling me about in their country that they have a cultural history of doing war dances before they would go into battle. And really it was bringing order. The dances were pattern-like and structured to bring about on a bigger level order in the middle of chaos.
Yeah.
And so I just kind of made that connection there. Anything in general is going to be a tug of war between order and chaos. So this is obviously something. And the other thing I learned is that, you know, they say we're like over 70% water, but if you really go molecule per molecule, we're over 99% water molecules.
Yeah.
So we're what's that?
Is all over the place.
Yeah, so we're really getting to, again, we're getting to the root of the root of the root. You know, so we've got the photodynamic therapy. This is actually a form of photodynamic therapy. It's just it's the route that it's, because you said it's a high infrared frequency.
Yeah, we're the infrareds, photodynamics are usually 6 to maybe 900 nanometers, somewhere thereabouts. We're up at a little over 1200 and 1600. So we're operating above those. And where we want to be and where we are the absorption peaks of water, because we want it absorbed by the water so it can be transferred to the body. And the other red light there, or the red light therapies, they are not at absorption peaks of water. They're you know, they're working in a different way through the cells, but they're very complementary.
And yeah, I mean, if we could do both, you know, if I think there's, you know, restrictions on, you know, how you create devices. My understanding is that, you know, because I always thought, well, it makes sense. Why don't we have like a machine that has both of them in one machine? There, the light and but it's more of a regulatory thing.
Yeah, don't even think about it. Just changing the power supply is a huge deal. I mean, it's really, the regulatory process for medical devices is pretty rigorous. And so when you start to combine things, it's just easier to leave them separate.
Okay. Yeah, I mean, you're probably more in touch with that but
so we have Dr. Cheryl. She's going to be presenting next week. Can you confirm that, Dr. Cheryl?
Yes.
Dr. Cheryl, are you there? Okay.
Yes.
I will depend on you, rely on you. So next week, Thursday, Dr. Cheryl is going to update us about COVID-19 because it's getting worse. And possibly after Dr. Cheryl, we're going to have Dr. Mike Beamer to talk about the update to manage COVID-19, especially with those new things. That's even here and overseas where I am right now, they have the lockdown from 6 to 6 p.m. and wearing the mask again. And I hear that the United States is reinstating wearing the mask again because of the number of the cases. But we're going to hear more from Dr. Cheryl next week about all the updates related to COVID-19. I think it's too late now. It's like 3:30 a.m. in the morning here in the US. I think it's like 10:30 in your place. So it's like 2 hours we are being talking.
Well, yeah,
right?
well, let's wrap it up. I'll only say one last thing is that with what I understand is that COVID, if there's, people say, well, they say, oh, it's diabetes, hypertension, it's, they have a higher or age. Well, if you really just look at it from the lens that, at least that I have earned over the past year, it really is a game of oxidative stress. So the more that, because if our mitochondria are optimal, the virus cannot hijack our energy system. If we are like broken down, then it can hijack and take over the system. That's how I see it. Kind of similar to cancer. So to have all of these things, I mean, I lay on a red light bed, the mat. I start off my day. That's my meditation. I lay on my back, and I have the Nanavi going on at the same time, because I know that physiologically I am reducing my oxidative stress much, much more than if I didn't do it. So I want to have that advantage. I think I lost my, I don't know if you can hear me, but let's conclude, and I guess we'll reconvene next week. So
yes. We'll see everybody next week, Thursday. Thank you very much. Appreciate everybody for coming. Thank you. Good night.
Thank you.
Yeah.